Okay. All right. The only other thing is, if you've just come in, we could circulate this sign-in sheet so that everybody has an opportunity to write their name in it, so that we get everybody signed in properly. Yeah, if you haven't signed in, just please take the opportunity to write your name on the sheet so that we know you were here. And as always, my name's Bruce. I'm going to be instructing you in this workshop. So I'll take you through just a brief recap of where we finished. We got done writing this function that writes a CSV for 1 year of our survey data. We've got our def here, which is short for define or definition, if you like. Def signifies to Python that you're starting a function. You have the name of the function, and then in parentheses you have any parameters you want to pass to that function, any arguments you want to pass to that function, a colon, and then the function code is everything that's indented after that. This string inside these triple double quotes, that is the doc string. That's documentation that tells you what your function does, and you see it if you run. I'm just going to run this to make sure that, yeah, you have to run the cell so that your function is defined, so that Python knows it exists. But if you run this question mark after your function name, like this, your doc string appears down here. You have a little built-in documentation for your function. This will work with any function. So if you see a function and you don't know what it does, if there's documentation for it, you can put a question mark after its function name and get that doc string. Just for example, if we take print, we run that, and we have the doc string for print as well. So useful syntax to have. If you ever encounter a function you don't recognize, you don't know what it does, you can type the function name followed by a question mark, and it will show you this doc string and tell you what the writer of the function wants you to know. So all right, we ran our function, and down here at the very bottom we can see that when we run the function with the year 2002 and our surveys data frame, we generated a function or a CSV file called function surveys 2002, which you will note up here. That's what we have decided to name our file. So, picking up from there, this is useful to be able to do. We can generate a CSV for a single year out of our survey data, but what we actually want to do, oops, hang on, sorry. My microphone was misaligned there for a second. What we actually want to do is we want to be able to make files for multiple years without having to request them one by one, as we would have to here. Because you can imagine how long it would take for 25 years. And if the survey was even longer, if it was a 50-year survey, or you weren't doing it by year, you were doing it by species type, and there were 115 different species, you can imagine that requesting them one by one would take a pretty long time. Fortunately, we can take the function that we've written here and we can build on it. So what we're going to do is down here, we're going to type def to define a new function, and we are going to call it yearly data CSV writer. And for the arguments that we're going to pass to it, we're going to be passing it start year, end year, and all data. And we'll put the colon there, hit enter, you can see we indent. What we're going to do with this is we are going to replace the entire for loop that we would use to iterate over a list of years sorry. With the 1 year function, we could write a for loop that would iterate over each of the years in our list and run that function for each of them. What we're actually going to do here is put that entire for loop inside a function so that rather than rewriting it every time, we can execute the entire loop with just a single line of code. And these parameters are going to let us execute it on an arbitrary number of years. So what we're going to do, we're going to add a doc string, which is good practice. And we'll say this writes separate CSV files for each year of data. And we're going to write underneath that what each of our parameters do, or what each of our arguments signify. So start year is going to be the first year of data that we want. End year is going to be the last year of data that we want. And all data is going to be the data frame with the multi-year data. Okay. So just a quick reminder, this docstring doesn't do anything from a functional code perspective. Your code will run fine without it, but it's really good practice, and it means that people who go on to use your code later will have a much easier time figuring out what you were thinking when you were writing it. So, as I said, we are going to use this function to replace the for loop that we would use to iterate over our 1 year CSV writer. So all we're going to do is we're going to put the for loop inside of this function, and then anytime we call this function, our for loop will run. So we covered the syntax of a for loop in the last workshop, but I'll touch on it real quick again as I write it here. We start with for, tells Python that we're writing a for loop. Year is our loop variable. That's what we're going to use inside of the loop to refer to whatever item in our list we're iterating over. And we're going to type in range start year and end year plus 1. You'll recall that range generates a list up to but not including the last boundary you provide. So if we put in start year to end year, we would go up to but not include the last year in our data set. So we want to go up to end year plus 1. That'll give us all of the years that we actually want to process. And then, like function definitions, to signify the code inside of the loop, you type a colon, and you'll note that when you hit enter after that, your code indents again. So now we want to write the code that will take the year that we're working with and write the CSV for it. Fortunately, we already wrote a function that will do exactly that. So we can use our 1 year CSV writer right here, 1 year CSV writer, and we can pass that year and all data. So our function for writing 1 year of CSVs is, like all functions, reusable. We can just drop it right in here. We don't have to just call it one by one on our own. We can use it as a component of future functions that we write. And similarly, if we had multiple data files, we could write a different function that looped through the files and called yearly data CSV writer on all of them. So we each function that we make is a reusable piece of code that we can deploy wherever it makes sense to reduce the amount of code we have to rewrite and to lighten our own workload. And another thing worth noting with this that we'll see in a bit, Because start year and end year are parameters that we pass to the function, we don't necessarily have to run this on our entire data set. We could run it on a subset of the data set. We could generate only files for 2001 to 2005 if we wanted to. The parameters give us the freedom to be arbitrary in the data that we actually want to generate. So I'll show you how we call this function. We gotta run this cell, make sure everything's fine. And we'll say surveys df equals pd.read CSV, reading in the CSV from the file, surveys.csv. And if we run that, sorry, I've just opened this notebook again, so there's a lot of code in here that I haven't run. What we have to do to resolve this error, telling us PD is not defined, I'll just scroll back up to, oh, I see, we haven't imported PD yet. All it's telling us is that we haven't imported PD, which you'll recall is the shorthand for pandas. So I will import pandas as PD. If I do that, the code executes without a problem. So having done that, we can now call our function. So let's say yearly data CSV writer, and I'm going to pass in 1977, which is the first year in our data set, 2002, which is the last year in our data set, and surveys df, which contains all of the data that we want to iterate over. If I do that, you can see that the function doesn't return any output. We're not making it print anything. But if we use the OS package, which that we do have to re-import, just like pandas, import OS. If we use os.listdir, I believe we called it yearly files, yes. Yearly files. If we run that, we can see there's our function surveys interspersed with our other survey data. Function surveys 1993, 1987, 1978, 79. They're not ordered very cleanly in here, but you can see that we have generated all of the relevant survey files, one for each year, using our function. Now, an important note for when you're writing functions in IPython notebooks, if you change a function, you have to rerun the cell in order to make those changes take effect. For example, if I go up here and I change this to say print, I've changed the function, pray I do not change it further. If I change the function thusly and I don't rerun the cell, when we run our function later on in our code, even though it's after the change we've made, you can see it doesn't actually, that change does not take effect. In order to make the change take effect, we have to rerun the cell itself that contains the function. We have to rerun the cell that contains the function that we've changed. If we do that, we rerun the cell, we rerun our function code, and you can see that our change has taken effect, which I'll get rid of that right now. Rerun the cell, and there we go. So, just a very, very important thing to know if you're writing functions in IPython notebooks. You might run into a situation where your changes are not properly taking effect. Before we go on, what are your questions? Is there anything else you'd like to know before we move on? No? Okay. Good, good. Okay. So, moving on. Okay, sorry. So far the functions that we've written, yearly data, CSV writer, writer, so far all of the functions that we've written demand that we give them a value for every argument. So every argument we have here, we have to supply something for that. We have to supply a value for that argument. If, for example, we ran this without an end year, you can see we get an error. We're missing one required positional argument. Interestingly, you'll note that it says we're missing all data. That's because even though end year is the argument we omitted, when Python is running your function, by default it will read your arguments left to right. So what it's assuming we've done is run yearly data CSV writer with 1977 for our start year, surveys DF as our end year, and nothing for our all data parameter. So this shows two things to do with writing Python functions. The first is that it'll read them left to right. It will, unless you specify otherwise, which we'll learn how to do in just a moment, it'll go left to right and assume that what you're passing it is in the order it's supposed to be passed. But also, it, again, by default, does not care about the type of data that you pass as an argument. We know that end year is supposed to be a number. We know it's supposed to be a year. But as far as Python's concerned, we've given it a data frame for end year, and if we put the third parameter back in the wrong order, we get a completely different error because it's trying to run this on a data frame. It's not trying to run it on a year. So Python doesn't know which variable you pass in is supposed to be which unless you tell it. It will go in the order you've defined in the function definition. So that's a thing to be aware of as you're writing and running your functions. Is you have to know what you're passing them. That was a little conceptual. So what are some of the questions that you have? Is there anything you'd like to know? Yeah.
What if you removed comma and then 2002, and then after 1977 you put a comma in between it, there's no value later on?
You mean if we put...
Just put a comma there, yeah.
Oh, like that?
Yes.
I believe... Yeah, that is a syntax error. So it doesn't like when you do that. We are going to learn how to not need to pass variables now, though. Because one thing that Python lets us do... Oh, before I move on, any further questions? Anything else anyone would like to know based on what we've been doing here? Cool. All right, let's move on to learning how to make our functions a little more versatile. One thing that Python lets us do is specify default arguments at the time that we define the function. So we can make it so that Python doesn't actually require us to pass in a value for every variable. One thing we can do is, yeah, okay, here we go. So we've got start year, end year, and all data. Now, I'm going to change what's in this this argument list. I'm going to start with all data. We're not going to create a default for all data, so it's going to remain a positional argument. Positional arguments, you saw that in the in the error message that we ran through a couple minutes ago, that when it told us we were missing a positional argument. Positional arguments are ones that are defined by their position in the function definition. So ones where Python knows what it's getting based on the order that, that you're passing them in. But default arguments. So we've got all data in there, and we are going to type start year equals 1977, and end year equals 2002. So what we've done here is when we write this out, where we've got our variable name, our argument name, and then an equals and then a value, what you're telling Python is, if I don't pass anything for start year or end year, assign 1977 to start year and 2002 to end year. So if we don't pass anything, it'll go ahead and use 1977 and 2002 for those values. You'll note that like I said, I've put all data first. Any arguments in the function that don't have default values, those are required arguments. They require a value like we used to have for all of them. And those arguments must come before anything with a default value. So we do have to reorganize it along these lines. When we call the function, anything with a default argument becomes optional. But anything that doesn't have one is still required. We still have to pass it. So I will, just to demonstrate a little more cleanly, I'm going to just make this return start year, end year. So rather than going through the whole loop, it'll just return our start year and our end year. I'll rerun this to make sure that our function changes. And I will say, yeah, okay, yeah, no, this is perfect. Yearly data CSV writer. If we get rid of this, when we pass in, say, surveys DF 1988 to 1993, so we pass in a start and end date. If we do that, it just returns 1988 and 1993. Those are the numbers we passed in. It's great. If, however, we don't pass those in, if we just pass in our all data frame, then when we run that, we instead get 1977 and 2002. Those are our default arguments. We haven't passed anything into the function, but because we've written in our definition what the default values are supposed to be, Python knows that when we don't pass in any values for those years, use the ones we've told it to use beforehand. So that's pretty useful to be able to do, because sometimes you're going to want to have a default value. Sometimes you're not going to want to pass in something for every single time you call the function. You're going to have times where you're using the same parameter over and over again with the same value. You have some default assumed argument that you only want to change sometimes. And that's where default values become really useful. Before I move on from this particular iteration of default values, what are some of your questions? We're good? Cool. Yeah, I'm seeing plenty of green Post-its, so things are going all right. So, super useful to be able to do. But what if our data set doesn't start in 1977 and end in 2002? Those values work as default arguments for this particular data set, but they might not work for all data sets. Not every data set is going to go from 77 to 2002. Some are going to be shorter, some are going to be longer. Some are going to be the same length but have 2 different years. So these default values work fine for this particular instance, but they're not very extensible. But we can modify our function so that it looks for the start and the end years in the data set itself if those aren't provided. I'll put this in a new cell because it's going to touch on some stuff that we haven't covered yet. Stick with me. We will get to the we'll get to conditionals in a moment. For now, follow along with the code. So I'm going to write def because we're making a new function here. I'm going to type yearly data arg test, yearly data argument test. And for parameters, we're going to use all underscore data. And for start year, we are going to say our default argument is none, capital N. You'll know that you've put in the right reserved Python keyword because the text will turn green if you're in IPython notebooks. What this is telling Python is the default value for start year is nothing, none, blank, empty, null. We're going to do the same for end year. End year equals none. And then we are going to go into our function body. Once again, we're going to put our docstring in here because it's good practice. And we're going to say this is this is modified from yearly data CSV, yearly data CSV writer to test default argument values. All data is the data frame with multi-year data. Start year is the first year of data we want. And I'm going to leave a note in here. Check all data. Default, none. This is good practice too. When you're writing out your docstring, be sure to include your default values so that people will know what they are. It's just a nice gesture of courtesy to have your default values in your docstring. And we'll also, we can't forget our last parameter, end year, the last year of data we want. And since this is also going to be derived from our data file, we are going to say check all data. Default, none. Okay, so that's a nice docstring. I'll scroll that up a bit so you can see. And now we get to the part where we're actually going to check for our start year and end year in our file itself. So, as I said, we're going to use a new control structure here called a conditional, which I will explain in more detail after we've wrapped up with functions. It's going to look like this. If start year is none, start year is going to equal the minimum using the min function, all data dot year. So one of the benefits of Python is that it reads almost like written English. And that's particularly clear here because what this means is if start year is none, then start year equals the minimum of all data dot year. So if we don't get a value for start year, we get the all data, or we get the year column from all data. We get the minimum value from it, and we say that's our start year. And whoops. And likewise, if end year is none, then end year equals the max of all data dot year. And we are also going to say return start year and end year. That's a fair amount of code. I'll give you a sec to just catch up. Then I'll also run the cell so that our function is defined. Nice. So once we've got this function, we can run yearly data arg test, and we run it on surveys df, and as before, we'll pass in 1988 and 1993. I've just a typo in the function name, but you can see if you get the function name wrong, Python doesn't know what to do with it. So that's useful to see. So I'll just fix that so that it's test instead of text. And we can see when we pass in 1988 and 1993, we get our start year and end year returned 1988, 1993. So we can still pass in arguments just as normal. And we can also, if we go the other route, yearly data arg test surveys df. If we rely on our default values this time, we can see we get 1977 and 2002, even though our default arguments are none, because we are checking for that possibility in here, and if they're none, we're deriving those values directly from our data. Right, so that shows off that none is a built-in constant in Python that indicates the absence of a value. The variable will exist in the namespace of the function, by which I mean it will behave like any other variable in the function itself. You can use it as a variable, but it doesn't correspond to any existing object. There's no data in it. So, and of course, if you pass in a default argument, start year and end year are not none, so those just get returned. Before we continue on to conditionals, what are some of your questions? Is there anything else that you'd like elaborated on? Insights, thoughts, comments? All right, cool. In that case, I'll use one of my existing tabs here. Just pull this up. I think you guys can try this challenge concerning variables. So, a couple of quick questions surrounding default variables that I'll give you a second to investigate. First question, what type of object corresponds to a variable declared as none? And there's a hint here telling you some of how you might be able to find that out. Take a little while and compare the behavior of the yearly data arg test when the arguments have none as a default and when they don't have default values, when you don't specify in the function definition any default values. And take a minute and find out what happens if you only include a value for start year in the function call. And can you write the same function call with only a value for end year? So I'll give you guys a little while to work on that. If you need me to put the code back up, if you didn't get a chance to write the whole thing, or if your code's not working, let me know. We can put it back up. And yeah, if you run into any trouble with this, use the orange Post-it note, yellow Post-it note, orange Post-it note, and pop that on top of your laptop. One of us will be around to help you. So I'll give you just a few minutes to try these on for size. All right. And I'll have a chance to check that out. So, let's see. Who wants to take a stab at question 1? What happens, or what type of object corresponds to a variable declared as none? Anybody give that a try? Sorry? Correct. We can see what that looks like over here. If we create a variable called test and set it equal to none, then we run type test. Sometimes it takes 3 times to spell a 4-letter word. If we run that, the output is none type. So helpfully, the type of a variable with none assigned to it is none type. You'll also see this sometimes in error messages, so it's useful to know what it corresponds to. If a variable is assigned properly or assigned improperly, or you don't get the data you think you're going to get, sometimes you can wind up with an empty variable set to none, and you'll get an error message saying concatenation can't be executed on none type, something like that. So it's useful to know what this represents. Moving on. Compare the behavior of the function yearly data arg test when the arguments have none as a default and when they don't have default values. Anybody want to share something that they learned experimenting with that? Anybody have any insights? No? All right, cool. Well, we can just take a look at that right quick. This is leading into our both leading into conditionals, but also circling back on some of what we worked out before. If we just get rid of these, and we say we don't have any default values for start year and end year, we can, of course, do that, but we also see here, if we try to run it without assigning those default values, we're missing 2 required positional arguments. So we haven't passed in start year and end year. So even though our default arguments were none, and we were just creating empty variables to hold data, if we don't define those variables, or if we don't define the default values, rather, Python doesn't know what to do with a function call that doesn't include them, even though they were just blank placeholders anyway. So that's if you're going to rely on values being none, you need to define the default values in the function definition. Because if Python doesn't know what to do with them, it won't do anything with them. It won't have anything to work with. And finally, what happens if you only include a value for start year in the function call? And can you write the function call with only a value for end year? Did anybody give this one a shot? I'm sorry, could you speak up just a bit? Mm-hmm. It'll take the value you pass for start year and the default value for end year. Is that what you said? Yeah. Yes. Okay. Good. That's what I thought. Yeah, that's right. If you take a value, or if you pass in a value for start year but not for end year, as you say, it will use the value that you pass for start year, but the default value for end year. So you don't have to, you can pass in variables if you choose for our arguments with default values, or you can not. Once you supply a default value, passing in something for that argument becomes optional. What about writing writing the function call such that it only such that you only pass in end year. Did anybody try that on for size?
So the first time I did it, I literally put the word none in when I did the function call for the start year, and it went fine. But when I actually created a new function that I basically just took the start year of the function call, and then I just set the variable within the function itself as an end year, where the year was equal to the minimum of all data.
Okay, so those are both options. You can pass in none for start year, and it will still get that. And of course, you can rewrite your function such that it only takes the one parameter. But I see. Yeah. Just this way? I think that is still a syntax error. However, there is actually a way to just pass in the end year without passing in, without having to pass in a start year, or even respect the position of the start year argument. I'm sorry? Correct. We can do this by, in the function call, specifying the name of the argument, typing end year equals 1988. If we run that, we get the default value for start year, like we got the default value for end year when we didn't pass it, but our end year is 1988. So in this way, by using the name of the argument itself, you can specify which variables, which values are assigned to each argument without having to respect their position in the function call, which is handy to be able to do, and also can make your function definitions a little more self-evident as people are going through and reading them. Yeah, I see a question. I'm sorry, like that? I actually don't know. I've never tried. Yeah, it doesn't, end year as a variable doesn't exist outside the scope of the function, so it doesn't know what to pass to it. Okay. And I'll just make that 1988 again to satisfy my neuroses about having errors on the screen. So, yeah, useful things to know about function definitions and function calls. Before we move on to conditionals, is there anything else you'd like to know? What are some of your questions? Well, I see you. Mm-hmm. Right. So the question is just how do we use os.listdir to only pass or to only search for functions with a particular pattern? Right. I'm not sure, but let's take a look here. os.listdir ? See if we might find an answer in the doc string. Path can be specified as either a string, bytes, or a path-like object. If the path is bytes, the file name's return will also be bytes in all other circumstances. List is in arbitrary order. os.list here, path equals none. If path is none, it uses the path dot in the current directory. If this functionality is unavailable, using it raises a not implemented error. So nothing in the doc string that gives us a clue. We might try a regular expression, just as long as I'm here. Yearly files slash function dot star. Okay, so it doesn't look like listdir is smart enough to use a regular expression right out. The short answer to your question is I don't know offhand. However, there is probably a way, if not with listdir itself, then there's probably something equivalent, I would think. I just don't know it offhand, I'm sorry.
I'm wondering if we use the shortcut, is it kind of like the sandwich or something that you press kind of like the line directly in the directory? I'm not sure how to explain it.
Yeah,
Not my question.
we can circle back on this after the workshop if you've got a sec. Yeah. For the time being, let's check out conditionals. So the body of our test function now has these two conditionals. Where is it? Here we go. Yeah. So these two conditionals that we've already written in there. Conditionals in Python, almost always to my knowledge, take the form of this if statement. And if statements execute a segment of code when their condition is met. If the condition isn't met, the code doesn't run. And they usually look something like this. If we say, we'll make a variable a equals 5, and we'll say if a is less than 0, we'll put a colon. So as with for loops, as with functions, we need to put a colon after this control structure, and the code indents, and everything that's indented is what will run inside of that control structure. So if a is less than 0, we're going to print a is a negative number. To get out of the body of the if statement, we're just going to backspace and we'll get out of the indentation. After the if, we're going to type elif, elif, which is short for else if. I'll explain that more in a moment. But elif a is greater than 0, we're going to print a is a positive number. And finally, outside of that, we are going to put else. Note the colons after all of these. So, else, if a isn't less than 0 and it's not greater than 0, it must be equal to 0. So we'll print a must be 0. So, if a is less than 0, print a is a negative number. Else if a is greater than 0, print a is a positive number. Else, print a must be 0. So if we run this cell, because a is equal to 5, we get, as expected, a is a positive number. If we change that to negative 5, we get that a is a negative number. And likewise, if we type in 0, we get that a must be 0. So this is a structure common to all conditionals. You start with an if. If some condition, execute some code. After that, you may not, have else if, or elif, elif in Python terminology. What that means is, if this hasn't executed, try this. So if this condition is not true, check if this one's true. So if, else if, and finally else, which means that if none of the conditions above are true, do what's in the else block. So if your first condition's true, execute that code. Else if, there can be any number of else ifs. But else if any of these conditions are true, execute this code. And if none of your supplied explicit conditions are true, run whatever's in the else block. One thing to note, if you can have as many else ifs, elifs as you want in the code in a single conditional block, but you can only have one if and you can only have one else. If you start a new, we can actually show off what that looks like. If we were to put if a not equal 12, print a is not 12. If we were to do this, put a second if after our first if, and run that, and -3, let's say. So we have now two conditionals because we have two ifs. So this is going to run everything above my hand here. If a is less than 0, print a is a negative number. See, we get that. And after that, this is all one conditional block because it's an if, an else if, and an else. So this runs as normal. We get a is not 12. So if you have a second if in your code, Python will treat it as a new conditional block. We don't want that in this case, so we're just going to get rid of that and just get a is a negative number. So that's basically how a condition looks, how a conditional statement looks. And that lets us look at these with slightly clearer eyes. These are going to check whether or not there's an object associated with the variable names start year and end year. If those variables are none, these if statements are going to register as true and execute whatever is in their body, which is in this case, start year is min all data year, end year is max all data year. On the other hand, if those variable names are not none, if they're associated with some object, some value, those statements are going to register as false, and whatever's inside won't return. All right. Before we continue on, do we have any questions about conditionals in a general sense? Anything else you'd like to know, have expanded on? Good. Great. I'm just going to quickly check the time. All right, we're still good. We got a little while. Okay. All right. And we've just briefly covered the keyword arguments, so good. Okay. We've got some time for another set of challenges. Oh, perfect. It's almost exactly the height of the screen. I find that very satisfying. Okay, let's check out the following challenges. As always, if you need any help, remember you've got the post-it notes. We'll be around to help you, but let's go through this. So, try taking a stab at rewriting one-year CSV writer and yearly data CSV writer to have keyword arguments with default values. So modify the arguments in the function definition to have default values. Modify those functions so that they don't create yearly files if there's no data for a given year and display an alert to the user. You can use conditional statements to do this, and if you really want to go above and beyond, you can do a little Googling and find out about try-catch statements. Those are pretty neat. If it feels a little daunting, you don't have to, but you're more than welcome. This code here checks to see whether a directory exists and creates one if it doesn't. So take this code and modify it to work with your code that writes out the CSV files to make sure there's a directory to write to. And finally, we've written through some code to loop through our years, but it's not necessarily reproducible with different data sets. We've talked about this in some senses before. For instance, what if we have additional years of data in our CSV files? So using everything that we've learned so far, make a list of all the years represented in the data, Then make a loop to process your data that begins at the earliest year and ends at the latest year using that list. And there's way down at the bottom here, you can create a loop with a list as follows: for years in year list. So give that a shot, give that a try. If you need any help, we'll be around to help. And yeah, I'll give you a little while to execute on that and see what you can turn up. Yeah, have fun with it. Okay, we're coming up pretty close on time, so we may not get through all of these. Anything we don't get to will be an interesting take-home exercise for you to bring back and play around with. We'll try to get through a few of these. The reason for that is next week we're going to be getting started on plotting, and plotting is, I assure you, very exciting and very new. So we're going to need all the time that we can get for that. But yeah, we'll start by going over some of these. So the first task to rewrite the one-year CSV writer and the yearly data CSV writer to have functions to have keyword arguments with default values. I'm sure that you are passing familiar with this at this point. Does anybody want to share what they used for their default arguments in doing this? Obviously, there's a lot of stuff that you could provide for a default argument. Does anybody have any suggestions for what they put in and why? Some of their rationale? Okay. For all data, I would go with none. If we're going to use a default value for this, all data is a pretty big data frame, and we're not guaranteed to always have something. So I would use none as the default, and I would check for none within the code, since whatever we pass in, if it's not a valid data frame with a year column at this point, is going to pose a problem for us. So that's always something to have in mind while you're doing default arguments. Yearly data CSV writer and one-year CSV writer. For this year and all data, we can also use none. This year, we could use none and use the same rationale as below. Say, if it's none, get it from all data. And all data, we could use none again for the same reasons as below. Put none in there, catch it, return out of the function if we don't have anything else to work with. Where am I at here? Finally, this I think is probably the last one we're going to have an opportunity to get to today, but anybody want to take a stab at number 2? How do you modify the functions so that they don't create yearly files if there's no data for a given year and alert the user? Anybody want to share how they tackled that one? All right. We can take a look at, where's my tab here? Okay. So to my mind, I think the best way to approach this is, since one-year CSV writer is, no data for a given year. Yeah, okay. Since one-year CSV writer is where we're actually writing the data, getting the data and writing it out, if we put this catch in here, that functionality will propagate up into our yearly data CSV writer, since we're calling this from within that function. And I will leave the code for you guys as an exercise to find out on your own time. But at this point in the code, I'll write in some comments here. This is where you would want to check that if surveys year is none. Actually, I mean, it's fairly, that's the nature of Python sometimes, is that sometimes the pseudocode that you write is actually valid syntax. If surveys year is none, if there's nothing in surveys year, if there's no data, then we can say print no data for, we can concatenate the year right onto that. So no data for this year. And this is useful to be able to do. if you're inside an if check, if you're inside a conditional, and you type return, in this case, I think I'll return this year, just because functions should return something. But if this block of code gets executed, if this conditional gets executed, this return will trigger. And when a return is triggered, none of the rest of the function gets executed. So if surveys year is none, we'll print that, we'll return this year, and this code that actually writes creates the file name and writes the file, that won't get executed. We'll hit the return, we'll pop out of the function, and the loop in yearly CSV writer will continue executing. So that's useful to be able to do. If you get into an if conditional and you want to exit the function when the code is executing, you can put your return right in there, and if your if condition doesn't trigger, if that code doesn't execute, the rest of your function will execute as normal. So that's everything that we're going to have time for today. We're at about time, so I should wrap up. I'm sure you all have classes to get to or work to do. Before you go, if you haven't signed the sign-up sheet, make sure you do. I think we got everyone, but you know if we didn't get you. And also, before you go, we really appreciate your feedback. If you could take the Post-it notes that you've got and write something constructive and positive, or something constructive that we could improve, something that didn't work for you that you'd like to see changed, write it on one of the Post-it notes. On the other Post-it note, write something good, something you liked, something that worked for you. Take both, stick them to the door on your way out, and we'll collect them. And use them to make future workshops better. Yeah. And I hope to see you all back next week. We are, as I said, going to be doing plotting with the plotnine library. So this is going to be the fun part where if you've got data that you want to visualize and things you want to, plots you want to make, charts you want to show people, this is where, at long last, we're going to cover how to do that. So by all means, I hope to see you all back next week.